Good afternoon, class. Here's exam 4 review covering chapters 4 and 5, application of differentiation integrals, and 6.1. And let's get started with the first part, covering 4.7, optimization problems, 4.8, Newton's method. So, chapter 4, I'm going to cover 3 more sections here. Then we cover chapter 5 and a section of 6.1. Again, we have this pledge. I pledge on my honor that I will neither give nor receive unauthorized assistance during this exam or any other exam for that matter. Reminding you of differentiation formulas. Power rule, trigonometric functions, the sum and difference formulas, product and quotient rules, chain rule, exponentials, logs, inverse trig functions, reminding you of delta y versus dy. Delta y is the change along the curve, which is this distance of BQ, and dy is along the tangent line, which is f prime of x dx. Linearization refers to finding the equation of a tangent line. Optimization. Find two numbers. There are some examples of that. Find two numbers whose sum is 54 and whose product is a maximum. So the idea is that number one, you got to define your variables. Let x and y represent the numbers. Therefore, you want to maximize the product. Let's say P represents the product x times y, and the constraint is the sum x plus y must be 54. Here's an example. And by the way, you can go with the first or second derivative test to prove it's an absolute max or mean. And the idea is that if you have a local extremum, okay, it becomes an absolute one if it's the one and only extremum in an open interval. Here's another example. If 5400 pi inch squared of metal is used to construct a cylindrical storage drum, what is the maximum possible volume? So here's the shape. As you know, a cylindrical shape, the volume is the area of the base pi r squared times the height. And we have 5400 pi inch squared of metal. That means gift wrapping. That means surface area. The bottom has the area pi r squared. It's a circular shape, and it's times 2 because the top is identical to that. The lateral surface, if you cut this open, becomes a rectangular shape where the height represents one side and the other side is the circumference of the base. So pi r squared times 2 pi r squared, and then plus 2 pi r h. That would be the surface area. It equals 5400 pi, and that's the limit. Now, let's look at this one and actually do this question. A farmer has 2,400 feet of fencing and wants to fence off a rectangular field that borders a straight river. He needs no fence along the river. What are the dimensions of the field that has the largest area? So first, you have to draw the setting. You have to define your variables. Let x and y represent the dimensions. A is x times y. That's what we want to maximize. That is the objective function. Given that we have 2,400 feet of fencing, the perimeter is normally 2 times x plus 2 times y, but this side doesn't need it, so 2x plus y is 2,400. So a is a function of two variables. We make it a function of one variable by solving for y here. Always use the constraint to solve for one of the variables. Put it back in there. And now, instead of a, we're going to call it a of x because it's a function of one variable. So having said that, x represents dimension, must be positive, and it must be less than 1200. So x must be larger than 0, less than 1200. Why is that? Again, larger than 0 because the dimension. less than 1200. If you set this one equal to 0, x becomes 1200. If you pick a x larger than 1200, this becomes negative. You can't have that. To continue with calculus part, and so far it's elementary algebra, we're going to distribute. And now we are ready for the calculus part, differentiation. We want to find all critical points. So we're going to differentiate and set it equal to 0. A prime is 2400 minus 4x. Set it equal to 0 and you get 600. Now we have an open interval of 0 to 1200, and there's only one critical point. So local becomes absolute. Is this a local max? Is this a local mean? We don't know. We do the second derivative test. If we differentiate this again, we get -4. A double prime is -4. And all we need is the sign. Remember, you have to plug in, but this is independent of x. That means regardless of the value of x, it will always be negative. Means concave down. And concave down means max because it looks like that. So if x is 600, you put it here to find the value of y, 1200, and the maximum area is the product of the two, which is 720,000 square feet. Here's another example of optimization. A box with a square base and open top must have a volume of 32,000 cubic centimeters. Find the dimensions that minimizes the amount of material used. First, I want to discuss the geometry or algebra behind this, reminding you a rectangular solid or prism, the volume is the length times the width times the height in any order. The surface area, if you look at the one facing us, the area is length times the height, and you have one, and the one in the back, two of them. The one on the side, the width times the height, and again, you have two of it, one on the right, one on the left. The bottom is length times the width, and we have two of them. And that's why the surface area is 2 times WL plus HL plus HW. Now, if all sides are identical, we call it a cube, in which case the volume is S cubed, the surface area, each side is S squared, so there are 6 faces, 6S squared. In this case, the base is a square, so let's define our variables, x by h. X by x because it's a square base. Otherwise, let's say x and y. So you want to be very careful the way you define your variable. So the objective is to have dimensions that will minimize the amount of material. The amount of material, that means gift wrapping. So if you want to gift wrap this, normally the base happen to be a square, so it's x squared times 2. We have 2 of them. Then the walls, each one is x times h. There are 4 of them, so 4xh. However, because the top is open, only 1x squared, not 2x squared. So S, 4 walls, 4xh, and the base, x squared. That is the objective. What's the constraint? The volume is this much. So x squared times h is 32,000. That is the constraint, the limiting factor in essence. So having said that, how do we solve this? Again, notice S has 2 variables, x and h. So we can use the constraint and solve for one of them, for example, h, by dividing both sides by x squared. Now we can replace the h here with 32,000 over x squared, and it becomes a function of only one variable, namely x. So obviously, 4 times 32,000 is 128,000. X cancels out the exponent here. So this is what we get. Now, To get it ready for the next step, which is differentiation, I'm going to bring x up, make it 128,000 x to the power minus 1. And x represents dimension. There is no other information, so x must be positive. In other words, the domain is 0 to infinity. Again, x represents dimension. So what do? We are going to differentiate, set equal to 0, find all critical points. So here's S. We're going to go with S prime of x. The product of these two is negative 128,000 x to the power minus 2 plus 2x. First and foremost, we're going to divide this by x squared and drop this. In other words, take x to the power negative 2 down, take a common factor of x squared. So this remains unchanged. This becomes 2x cubed. So you have a fractional format. So a fraction is 0 if the top is 0. A fraction doesn't exist if the bottom is 0. The bottom is 0, x becomes 0. It's not part of the domain. So let's set the numerator equal to 0. This means 2x cubed equals 128k or 128,000 divided by 264k. Take a root is 40. Cube root. So what do we have? Open interval with only one critical point. So local becomes absolute. Now, is this a local mean or local max? Let's check with the second derivative test. To do that, we are going to go here. And we are going to use this one. S double prime is the product of these two negative numbers becomes 256,000 x to the power negative 3 plus 2. The second derivative test implies that we have to plug in and observe. So we have 256,000 divided by x cubed divided by 4d cubed plus 2. You don't even have to know what the answer is to recognize this is positive, because positive over positive is positive, plus 2 is even more positive. It's 6. What is the significance of being positive? Concave up means minimum. Why? Concave up looks like that, and here's the minimum. So minimum occurs when x is 40. So if x is 40, you put it in here, x is 40, 40 squared times h is 32,000, and you get h equals 20. That's 32,000 divided by 40 squared, or 1600, gives you 20. So if x is 40, h is 20, we write the dimensions. X is 40, x is 40, h is 20. Those are the dimensions. They didn't ask what is the minimum surface area. However, we can just evaluate it 4 times x, 40 times h, 20 plus x, 40 squared. We get 4,800 centimeters squared, just in case. So optimization. You have to come up, besides drawing if need be and defining your variables, you have to come up with two things: objective function and the constraint. Use the constraint to solve for one of the variables, put it into objective function to make it a function of one variable. You must come up with the proper domain and take it from there. Having said that, what is the minimum distance between the parabolas y equals x squared plus 1 and y equals x minus x squared? I'm going to assume everybody can graph the parabolas nice and easy. So after we graph them, so somewhere we have the smallest distance. Clearly has to be some sort of a vertical distance. So we may not know where it happens. So we just make up 2 points. And what are the coordinates? If the x coordinate is x, of course, they both have the same x coordinates because it's a vertical. Then this one has the yx squared plus 1. This one has the yx minus x squared. So the vertical distance is just the distance between the y coordinates, the top y, which is x squared plus 1, minus the bottom y, which is x minus x squared. So that's the distance. We call it a vertical distance, x squared plus 1 minus parentheses x minus x squared. Now, of course, x squared plus 1 minus x plus x squared. We have 2x squared minus x plus 1. And we got to go with the domain. We don't know where x is. Wherever, it could be anywhere. So from negative to positive infinity. That would be the domain, which is an open interval. So we are going to go with calculus. Now, everything so far has been algebra. V prime for x minus 1. We set it equal to 0. X becomes 1/4. So we have an open interval of negative to positive infinity. We have one critical point. That means local becomes absolute. So having said that, we're going to go with the second derivative test. V double prime is just 4, which is a positive value. Remember, you have to plug in, but it's independent of x. Positive means concave up and therefore minimum. Again, also if you plug in, that's what it means. There's not much to it because it doesn't involve x. Concave up means minimum because concave up looks like this. So that's where the minimum appears. So minimum at x equals 1/4. What is the minimum distance? Plug it into the v function. Now you can do it here or just here. Two times 1/4 squared minus 1/4 plus 1. I hope you see that this is 1/16 times 2 is 1/8 minus 1/4, 2/8 plus 1, 8/8, and we get 7/8. Precise answer. A cylinder is inscribed in a cone with height h and base radius r. So the height and the radius of the cone is fixed. Find the largest possible volume of such a cylinder. You have to draw for sure. So the cylindrical shape is inside. It can be like, just for the sake of argument, you can make it maybe thinner, or you can make it shorter. We don't know. So we just put something in there and we are going to work on it with the calculator. So I'm going to erase my work. So I want to make a point that it could be just anything, right? But we figure out which one will give us the maximum volume. So let's define our variables. We are going to say this piece is y, this piece is x, this is r and h. R and h are fixed. So this distance and this distance, this is the radius of the cylindrical shape. This is the height of the cylindrical shape. We're going to call it same. It's a different R, so capital R versus lowercase r. Remember, these two are fixed, capital R and capital H. So this cylindrical shape must have a largest possible volume, and the formula is pi r squared h, both of them capital. So we're going to use, since we call this x, so capital R is x, and h, capital H, is lowercase h minus y. So R is x, and capital H is this distance h minus y. So I hope everybody is clear on that. I like to go with x and y. You can keep it as r if you want here. Then r becomes a independent variable that you're going to work on. So having said that, the volume becomes pi capital R x squared, capital H, h minus y. So you write it in this fashion. And I hope you see, if you look at this part, is a triangle, and this part. And you just concentrate on that triangle. What do we notice? This distance is y, this distance is x, this distance is lowercase r, this distance is capital H. And this one is h minus y, obviously, just in case. So as you recall, in the case of similar figures, corresponding angles are equal, corresponding sides are in proportion. So this small one this is the small triangle, is similar to the large one. So for example, x over r is the same as y over h. So the idea is to make this, if remember, there are two variables here. We want to make this a function of one variable. This is a function of x and y. So over here, we can either solve for x or y. So if I do the cross product, y becomes hx over r. I'm going to replace that, and that becomes a function of one variable. Now let me erase my work. So pi x squared h, pi h over r x cubed, because we are going to differentiate, so we want to separate the x, or in this case, x squared x cubed. Now, what is the limitation on x? If x represents the radius of a cylinder, has to be larger than 0, otherwise there is no cylinder, and it has to be less than the radius of the cone because it's inscribed in it. So x must be between 0 and lowercase r. So that's the domain that you have to make a note of it. One more time. Why is it positive? Because if it's 0, there is no cylinder. Why is it less than r? Because r represents the radius of a cone. If it's equal to r, it will be actually outside it. So having said that, let's go with calculus now. V prime. To differentiate, this is pi h times 2x minus pi h over r times 3x squared. To set this equal to 0, we're going to factor out the pi and h and x. If I take pi h x out, this gives me 2. Pi h x out minus 3x over r. So There are two answers. If we set this equal to 0, either x is 0 or 2 minus 3x over r is 0. Either x is 0 or 2 minus 3x over r is 0. And you can get rid of this, put the equality here, and then times r over 3. See, this one is 3 over r. Let's multiply by the reciprocal. We get x is 2/3 r. So either is 0 or 2/3 r, and obviously 0 is out because x is between 0 and r. In other words, if we were to write it in an interval notation, we would write 0 to r. R is a fixed number, the radius of the base of the cone. All right, so 0 is out. You have an open interval with one critical point. It is going to maximize or minimize, we don't know. So we have to check. We're going to go with v double prime. So we go back up here, differentiate it, okay? We get pi h times 2 or 2 pi h. This one we get minus pi h over r times 6x. We get 6 pi h over rx. So one more time. This one, we just get rid of the x. We get this one. And this one, instead of x squared, just change x squared to 2x and you get this one because we're differentiating. So what do we have to do? What is the second derivative test? Second derivative test, we have to plug in and observe whether it's going to give us a positive or negative value. That's all we want. So let's plug in 2/3 r instead of x here. So this is 2 pi h minus 6 pi over r times x is replaced with 2/3 r. So 6 times 2, 12 divided by 3 is 4. Or from the top and the bottom cancel each other. So we have 2 pi h minus 4 pi h, which is negative 2 pi h. And how do we know it's negative? This is a negative value. Pi and h are both positive. So that makes it negative. Negative means concave down, means maximum at x equals 2/3 r. Now, what is the largest possible volume? Well, we're going to plug in to this pi hx squared minus pi h over rx cubed. I can factor out pi hx squared 1 minus x over r. Now I'm going to replace the x with 2/3 r here and here. So pi h, 2/3 r quantity squared, 1 minus 2/3. 1/3, 4/9, r squared. We get 4/27 pi r squared h. And again, please understand that this one is 2/3 r divided by r. The r cancels. So, to recap, first we inscribe a cylindrical shape inside a cone. We define our variables. We write the volume of the cylindrical shape. Because it's a function of two variables, using similar triangles, we get rid of one of the variables. We make the volume function of one variable, and we move on with calculus. All right, what about Newton's method? What is that? Consider a function as it crosses the x-axis. In other words, look at the root of a function. So here's a function, and it crosses the x-axis at this point, for example. Newton noticed that tangent line close to the root crosses the x-axis nearby. Tangent line intersection. And we know this is the equation of a tangent line. Y minus y1 equals m times x minus x sub 1. So for example, somewhere here, for example, x sub 1, if we draw a tangent line, clearly the tangent line, so this is the root for the function f of x. This is the root for the tangent line. Are they the same? Absolutely not. But notice they are extremely close, and that's the method that is known as a Newton's method by using that as a new point. So having said that, y minus y1, so y minus f of x sub 1 equals mf prime of x sub 1, x minus x sub 1. So this is using the point slope form of a tangent line, everybody. Now, where does this tangent line cross the x-axis? Well, wherever it crosses, the y must be 0, right? So if we set y equal to 0 here, and we move this and divide by it, you get x minus x sub 1. If I move minus x sub 1, then becomes x sub 1 minus f of x sub 1 over f prime of x sub 1 equals x. So this x is the root of the tangent line. And we're going to use this as the second point. So use that point as a second and usually better estimate. Sometimes it may not, it depends. If f prime is close to 0, this gets worse. Estimate for the root of the function. So you have x sub 1, then x sub 2 is here. So you draw the tangent line here. That's the idea. So x sub 2 is x sub 1 minus f of x sub 1 over f prime of x sub 1. So we call it x sub 2 rather than just x. If we continue, x sub 3 is x sub 2 minus f of x sub 2 over f prime of x sub 2. Repeated application of this process is called Newton's method. And f of x sub n plus 1 is x sub n minus f of x sub n over f prime of x sub n. So we're going to go over the synopsis of that and an example. So to recap, consider a function as it crosses the x-axis. So here's the function, and it crosses the x-axis at this point, called the root. Newton noticed the tangent close to the root crosses the x-axis nearby. So if you look at the tangent line, we are not saying this, which is the root of the tangent line, is the same as this one. We are just saying it's nearby. That's all we know. And x of n plus 1, we said x of n minus f of x of n over f prime of x of n. So if we start with somewhere as x of 0 and draw a tangent line. Take a look at this graph. It makes it really nice and easy. You draw a tangent line, and the tangent line crosses the x-axis at some point. We're going to call it x sub 1. Now, at x sub 1, if we draw a new tangent line, it crosses the x-axis somewhere else, x sub 2, which is much closer to the root we are interested in finding. And that's the idea. So again, we are repeating with different, pictures to make it easy to understand. So take a look. This is the tangent line crosses here. Now over here, you draw a tangent line. Take a look at the second tangent line. Now the second tangent line has a point, has a root that is much closer to what we are looking for. And this thing continues, and it gives rise to this. And here's a calculator program when, just for this question, you may use a calculator program when you show work for the first few steps. What do I mean by that? I'll show you a simple example. You know exactly what I mean by that. So having said that, let's start with this example. Calculate 3 iteration of Newton's method to approximate the zero of f of x equals x squared minus 2, and we start with x sub 1 equals 1. If in most cases, they give us the point to begin with, but if they don't, then we have to figure out what to do. So having said that, let's see what's going on here. So f of x is x sub 2 minus 1. We have to differentiate. We get 2x. So x squared minus 2 is a parabola that it's coming down by 2 units. So that's why this is 0, negative 2. And so we start with x sub 1 being 1 here. And right here, this is the point, and this is the tangent line. Obviously, the tangent line. So again, this is the root, everybody, root of the original function. This is the root of a tangent line, x sub 2. Okay. And so if x sub n plus 1 is x sub n minus f of x sub n over f prime of x sub n, x sub 2 must be x sub 1 minus f of x sub 1 over f prime of x sub 1, which means, what is x sub 1? 1 minus f of 1 over f prime of 1. So you have to show the function, you have to differentiate, show f prime of x, and you have to show, okay, starting with x sub 1, here's how we get to x sub 2. So 1 minus, what is f of 1? 1 squared minus 2. What is f prime of 1? 2 times 1. This is negative 1. This is 2. This is positive 1/2. So we get 1.5 or 1.5. So that means x sub 2 is 1.5, everybody. So at 1.5, if I draw it, so 1.5, somewhere here, and then you draw a tangent line. Notice the green one is hitting the x-axis very close to the actual root. So again, with this one, we're going to say now this was x sub 2. We're going to go with x sub 3 is x sub 2 minus f of x sub 2 over f of f prime of x sub 2. So that means now we are going to use 1.5 here. So 1.5 minus f of 1.5, you plug in here 1.5 squared minus 2, and 2 times 1.5, and you end up with 0.25 over 3, and you get, and you write a bunch of decimals. Normally, they tell you how many decimals. So 1.416667. And we want to do one more because they said 3. They gave us 1. We need to do 3. So that means x sub 4 is x sub 3, f of x sub 3 over f prime of x sub 3. Now, this is what I mean. At this point, this number becomes tedious. So that's why maybe you use a calculator and a methodology that I'm going to go over in a moment. So back here, we're going to plug in, and using a calculator, we come up with the answer. That's the idea, everybody. Again, I hope you see that if I were to continue, then this becomes pretty involved. I'd use Newton's method to approximate the 8th root of 500 to 8 decimal places. And so first and foremost, we want to come up with the function. So we let x represent that. Clearly, if x is that, if we're going to raise both sides to the power of 8 to get x to the power of 8 is 500. And now we bring them to the same side. For example, this way, x to the power of 8 minus 500 is 0, and we call it f of x. So let f of x represent x to the power of 8 minus 500. What it means is that this function, if we find the root of this function, the x-intercept of this function, that's the answer to the 8th root of 500. I hope you can see and you can follow. So we need to differentiate, and f prime is 8x to the power of 7. So I hope you see that if this question is given, you have to let it be x. X to the power of 8 is 500. Come up with the function, differentiate, and write the general format. So x sub n plus 1 is x sub n minus x sub n to the power of 8 minus 500 over 8 x sub n to the power of 7. Now, where do you begin? Because it's not given. I hope you know that you can, use a calculator to see that the 8th root of 256 is 2, the 8th root of 61 is 3, and you can start with one of them, for example, 2. And by the way, if you don't have a calculator, maybe you're going to get something closer, okay? It's because it's between 2 and 3, like maybe, I don't know, 2.5. But anyways, continue until they agree to how many 8 decimal places. That's the process. So I'm going to look at a couple of them. So for example, the first one we decided to go with 2. Now we're going to go with x sub 2. So x sub 2 is x sub 1 minus x sub 1 to the power of 8 minus 500 over 8 x sub 1 to the power of 7. So using this general format, I'm going to go from x sub 1 to x sub 2, and I'm going to plug in 2 here, 2 here, and 2 here. Now, 2 to the power of 8 minus 500, negative 244 over 1024. And I'm going to give you an exact answer, although you can use a calculator. But the bottom line is, with x sub 1 being 2, x sub 2 with a bunch of decimals is this number. Now, because I have shown step by step how I arrived at the function, what is the general format? What is the function? What is the derivative? I came up with the first one, and I showed detailed work for x sub 2. Now, if I use a calculator, it's okay because I've shown all the work that I need to show. And so having said that, this program says you use a graphing calculator and you put f of x into y1. F of x is what? In this case, x to the power of 8 minus 500. Then you put f prime into y sub 2. In this case, is 8x to the power of 7. And then you start with x sub 1 and you store it in x. X sub 1 happen to be 2. With the arrow, you store it in x. Then x minus y1 over y2. We are writing this formula and store it in x, and it gives you this number. If you hit it repeatedly, remember how many times you should do that until you get 8 decimals that are the same, just for the sake of argument. This one, the first 3 are the same. Do you see that? 174, 174, then it changes. So you have to continue. So if you go a couple more times, you notice we want how many? 8. So 1, 2, 3, 4, 5, 6, 7. Number 8 is 7. 1, 2, 3, 4, 5, 6, 7. And this is 7. Up to 8, they are identical. And we're going to stop. And because next to it is 6, we take it up by 1 notch. And we say with 8 decimal places, we have 2.174555928. You have to absolutely justify your answer. So this is how you work with that. Use Newton's method to approximate the positive root of this function, 3 sine x equals x to 6 decimal places. So first and foremost, we need to come up with the graph. One way to do that, this one, y equals 3 sine x, we come up with the graph. This one, y equals x, we come up with the graph. And point of intersections are interest to us. And I hope you see these are points of intersection. And since we want positive root, we are interested in this one. So we take him to, so this is the point of intersection. We take him to one side, doesn't matter, x to that side or this one, and say we call it f of x. Now this function, if we find the root of this function and using the Newton's method, that's what we are interested in, and we'll get to the answer. So we need to differentiate. F prime of x would be 3 cosine x minus 1. And we're going to write x sub n plus 1 is x sub n minus f of x sub n. This one, 3 sine of x sub n minus x sub n over f prime over this one, 3 cosine x sub n minus 1. So that's the general form. And so we are going to write x sub 2 is x sub 1 minus 3 sine x sub 1 minus x sub 1 over 3 cosine x sub 1 minus 1. And at this point, where would you begin? And I hope you see the graph tells you, well, 2 is close. Even if you start with like 1.5, it works, but 2 is close. So why don't we start with 2? So we're going to write x sub 2 is 2 minus 3 sine 2 minus 2 over 3 cosine 2 minus 1. Now, this obviously clearly requires a calculator because 2 may mean 2 radians, and we do it with a bunch of decimals. Now, at this point, again, this is getting tedious. You may use a calculator by writing y1 is the function 3 sine x minus x. Y sub 2 is its derivative 3 cosine x minus 1. And store 2 in x, then x minus y1 over y2 in x, and you get this number. So here's x sub 3. If I stop here, see 2.2799594 becomes 5. And I continue and I get this one, and I want 6 decimals. Take a look. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Okay. They are identical. Okay. And next to 2 is 8 or 6. Then this is x sub 4. X sub 4 will do the job. We don't want to go with x sub 5 because this is the same as x sub 5. Ultimately, call it x sub 4 is 2.27886. And 2 changes to 3 because the number next to it is 8. And that's the final answer.